As we consider the different ways that a router could learn about IPv6 routes, there's three basic categories, very similar to what we have in IPv4 as well. One is we can have a router that's directly connected to an IPv6 network. Boom! It knows how to reach that network, has an interface directly in it. Two, we can configure static routes, which needs to be done after we configure the actual interfaces with the IP addresses. So static routes is the second option for configuring our devices to learn how to route with IPv6. And the third is using a dynamic routing protocol of some type so that the routers can talk to each other and dynamically learn about how to reach remote IPv6 networks. So in this lab, and I encourage you to do it hands-on the next time you have an opportunity at a desktop or laptop to log into the CBTNet site, I'd like you to click on the link for Virtual Lab and follow along with me as we configure our base topology with directly connected IPv6 networks, and then we'll build on top of that. So as a reminder from the previous video, and pretty much a reminder for myself, this is the network that we're going to use. This X represents these individual networks that we're going to be putting in between the devices right there. And we're going to do link local addresses also for R1, R2, and R3 with FE80::, and the router number being used. Also for the global addresses, we're also going to use the router number to make it very clean and easy to identify where an address is. All right, so here we are on DCNUG. It's our administration machine. We'll log in. Let me go ahead and bring up our topology image right here. So I have it handy, so if I need to look at IPv6 addresses, I can. Great. And then we'll bring up PuTTY and we'll connect to all three routers. So we'll click on the servers tab over here on the left, go to router 1, do it again, go to router 2, do it again, go to router 3, and then just clean it up a little bit so it's nice and pretty just by going to each screen and pressing enter a few times, and we are good to go. All right, in fact, let's talk about our game plan. All right, so here is our game plan, and if we're consistent, it'll help us in getting it correct. What we'll do is we'll go to each of the routers, R1, R2, and R3, so the interfaces are 0, 0, and 1, 0. We'll bring those interfaces up. We'll do that with a no shutdown command. And then we'll do the IPv6 address command, and we'll add the link local address of FE80 with the router number there. And then we'll specify that's a link local address. And then we'll also do the global addresses on each of the interfaces. 2001, DB8, 6783. So let's call this Y to represent the actual router number. This will be 2001 DB8 6783, and then X : Y to represent the router number. And then we'll use a /64-bit mask, splitting that IPv6 address right down the middle. Okay, so that is our plan, and along the way we'll do some commands for show IPv6 interface brief and show IPv6 route just to verify that we're making the progress that we hope to be. All right, back to the interface. So we'll start on R1. Let's do a show IPv6 interface brief. We shouldn't have anything yet. Great. All the interfaces are down. No IPv6 addresses. Great. So let's go into configuration mode. And let's go into interface gig 0/0 and do a no shutdown. So far, so good. And then we'll add an IPv6 address. And the address we're going to add is FE80::. This is router 1, so we use 1 there. We'll specify it's a link local address. Press enter. Boom, got our link local address and IPv6 address. I can tab that out to expand it there. And the global address is 2001:DB8:6783:, and I'm going to take a look at my topology again. So right here, this network off of 0, 0 and R1, it's going to be network 1. So instead of the X, we'll put a 1 there and continue on. So that's 1::1 with a 64-bit mask. Boom. I think we did great. Let's verify what they do. Show IPv6 interface brief. And okay, great. We got the link local address. We have the global address on that interface. It's on to interface gig 1/0. So interface gig 1/0. No shutdown. IPv6 address. And we use the link local first. So we use that same address again on the other interface. And then we'll specify it's a link local address, press enter, and then we'll add, I'm going to use the up arrow key and cheat a little bit, and then I can just replace this IPv6 address. Instead of network 1, we'll go ahead and call it network 12, and that should work. Boom. And then we can verify our work with a up arrow key a few times with a show IPv6 interface brief. Wonderful. Both interfaces, both up, and it looks like they both have the correct addresses that we assign. Fabulous. All right. We'll type in end. We'll go over to router 2. Here on router 2, same thing. Config T, interface gig 0/0. No shutdown. IPv6 address for the link local is going to be FE80::2 this time. We'll specify that's a link local address, and then IPv6 address of 2001 DB8:6783:, and this network on R2, let's take a look at our topology real quick. This network on R2 is the 12 network off the 00 interface. So we'll go ahead and put 12 there. And then the host address is 2 on this bad boy with a 64-bit mask. All right, so we brought it up, gave it a link local address, and also gave it a global address. Great. On to gig 1/0 here on R2. And we'll bring it up. Hit the up arrow key a few times. So the link local address is going to be FE80::2 on this side as well. So both interfaces have the same link local address of FE80::2, but it's cool because it's only used on one network at a time. It's not a globally routable address. So we'll press enter on that. We'll hit up arrow key a few more times, and we'll change this interface gig 1/0 to be network 23 as this reaches out to the network that's being shared with R3. And the host address is ::2. Great. Boom. Done. And we'll do a quick verification. Show IPv6 interface brief. And I got to spell brief correctly. There we go. That looks great. And let's do a show IPv6 route. And I'll also go ahead and do connected, just to weed out the herd a little bit. And there's our 2 directly connected networks, hence the C there, and from the code meaning connected. So we have the 12 network and the 23 network on 00 and 10 respectively. That looks great. Let's go on to router 3. And here on router 3 it's the same process. Interface gig 0/0. Bring it up. IPv6 address for the link local address, FE80::3. Sometimes you get in a little habit. It's like, oh, now it's 3, not 2. So we'll put that in along with the keyword meaning it's a link local address, IPv6 address, 2001 DB8:6783:, and this is network 3 on this side, :3/64-bit mask. Boom. And did we bring that up? Yep, we did. That looks good. So we'll go over to interface gig. Oh, that's the wrong network. I got ahead of myself. So it's good to see that because we can make sure we're on the same sheet of music. So we just configured gig 00 on R3, and I gave it the network of 3 instead of 23. So this is an important step. Because an interface can have multiple IPv6 addresses, we don't want to just overwrite it. With IPv4, by default, it'll overwrite the IPv4 address because it's not expecting to have a bunch. But with IPv6, the best thing to do here would be say no, and then take that IPv6 address that was incorrect because of my mistake there, and right-click, paste it in, take it out, make sure it's not there, and then hit the up arrow key a couple times and put in the correct network, which is 23. Great. Okay, interface gig 00 is good. Let's go to interface gig 1/0. Hit the up arrow key a few times. Give it the link local address of FE80::3. Link local, fantastic. And we will give it the correct address here on the 3 network by updating that as well. So no shutdown. All right. Woo. All right. Good practice with IPv6, and I would love it. I would love it if everybody would do this in the lab as well. You can use the virtual lab that we're providing and walk through it to get the hands-on practice, or if you have Viral, or if you're using some other simulator or emulator or packet tracer, that would be a great way to practice as well. But either way, any way you want to do it, make sure you get the hands-on practice, and let's verify a few things too. Let's do a show IPv6 interface brief. Also, you'll notice that as you become more familiar with IP commands, you'll forget to type in v6. It happens to me still, so I have to make a conscious effort. So the gig 00 and gig 10 are both up. They both have a correct link local address, and they both have correct global addresses as well. So we should try to ping something. Let's think about what might be pingable. Because we just configured these 3 routers, these routers should be able to ping their immediate neighbors. We can't route outside of our local networks yet because we don't have dynamic or static routing in place, but we should have, with these directly connected routes, we should be able to reach each other. So because we're on R3, we could do a quick ping over to R2 at 2001 db8 678.323.2, and that should work if we've done everything correctly. So let's do that. So ping. Now with ping, this is interesting and fun. Ping is not just expecting IP. So if we ping and put in an IPv6 address, it's assuming we're doing an IPv6 ping. If we do a ping, we put in an IPv4 address, it assumes we're doing an IPv4 address. If we want to be very clear, we can actually put in the type of ping that we want to do as well. You can actually add IPv6 if you want to, or you can just put in the address. So we'll put in 2001:db8:678:3:23:2. And what do you think? What do you think the odds are of this working? Now we know that R2, it has those two networks. The interfaces are up. The IP addresses look correct. I think we're in good shape. Let's go ahead and press enter. And this is where if it doesn't work, we would want to go back and take a look at, okay, are all of our interfaces up? Did we put the correct IP addresses on them? We should also be able to ping the link local addresses. So if we do a ping FE80::2 from R3, output interface is gig 0/0. I had to ask because it's got two link local addresses on two different interfaces. So we'll specify the exit interface, press enter, and it wants the full thing. Oh, thank you very much. Gigabit Ethernet 0/0. Oh, it didn't like the space. Hold on a second. Without the space. Oh, and I was making fun of it too. Let's go back. Let's go back and do the ping here again, and we do gig 0/0 without a space. Ah, yeah, okay. So it wanted the full name and no space. So we gave it what it wanted, and it also was able to verify. You know, it's tricky. You kind of got to give the machine what it wants based on the syntax. So what we've done is we have configured the IPv6 link local and global addresses on each of these interfaces. When we did so, when we put the global addresses on there, each of these routers now has two directly connected IPv6 global networks that it knows how to reach because they're directly connected. And this sets us up in perfect striking order, perfect striking distance for now adding static routes to increase our reachability. Because currently R3 doesn't know how to get to the 12 network or the 1 network. R1 doesn't know how to get to the 23 network or the 3 network. So we can solve that by implementing some static routes. And that's what you and I get to do in the very next video. We'll go ahead and sit down and strategize on our options, like IPv6 default routes and IPv6 network routes, and where could we put them in. And then once we have our plan in place, we'll actually do it, configure it, and verify that they work. So all that and more is coming up in the very next video. So I'll see you there in a few moments. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.